Question 3. A 0.216 gram sample of aluminum carbide reacts with excess of water to produce methane gas. This is the only carbon-containing product formed in the reaction. After that, the methane gas burns and forms the H2O and CO2. The volume of CO2 produced at room temperature is 108 cm3. So first, the sample is aluminum carbide, which there are two elements in there, aluminiums and carbon. And the carbon from aluminum carbide will form methane gas after it reacts with water. So means we can use the CO2 that produced from the combustion of methane, find the carbon mass. That's the first thing we need to do. We need to get the mass of carbon, then we can get the mass of aluminum. So means we need to start from the volume of CO2 in order to get the mass of carbon. So we use 108 cm3 over the molar volume. So this one is the mole of the CO2 that produced times 44. 44 is the molar mass of the CO2. So we will get 0.198 gram of the CO2 that produced. So means 108 cm3 we will get 0.198 gram. Okay, but this is not the answer yet, because this is CO2. We need to know the mass of the carbon. So how to get the mass of carbon? We need to use the mass fraction. Means in the CO2 there is a one carbon there. So CO2. So the carbon mass is 12. Oxygen is 32. So we need to get the mass fraction of the carbon using the mass of the carbon over the molar mass of the CO2. So this is the mass fraction of the carbon in the CO2. So use this mass fraction times the mass of CO2, we will get the mass of carbon now. So this is how we get the mass of carbon, okay, from the mass fraction and the mass of CO2. Okay, once we get the mass of carbon, we can get the mass of aluminum, because in the sample just now there are only two elements, so which they are aluminiums and carbon. So we just need to use 0.216 minus 0.054. So the mass, the remaining mass, is the mass of aluminum. So now we get the mass of carbon and the mass of aluminum. So we can find the mole of these two elements. So use the mass over its molar mass. So for the aluminum, we will get this mole. For the carbon, we'll get this mole. After that, we divide these two moles with the smallest mole. Let's say divide by 4.5 times 10^83. So we'll get this ratio. Aluminum is 1.33, carbon is 1. So after that, all times 3, we will get the whole number, 4 to 3. So means now the formula for the aluminum carbide is Al4 C3. So answer is D. Okay, that's all. Thank you.